Today, I'm going to do what I call real math. Not just some computations to find an answer, but to actually derive some useful formulas, namely for the concept of amortization. Kind of a hard word for me to say, amortization. Anyways, just a quick preliminary background on the concept, because for whatever reason, it used to kind of scare me just hearing that word. Honestly, it's not even that difficult to understand. To amortize a loan, all it really means is that you're paying off a loan. Okay, in this case, my loan is L. I'm making payments. Okay, and each payment consists of a portion which is paying the principal, so going towards the principal, and a portion which goes towards the interest. So that's what it means to amortize a loan. Make payments, paying a portion of principal, paying a portion of interest. Now what I want to do in this video is I want to actually derive some formulas related to amortization, namely um, for each period you pay a certain portion of interest and principal, and I want to figure out what that is because it's not the same every period. And actually what we'll see, hopefully if I get to explain it, is that the first period I pay the least amount of principal relative to the other periods and the most amount of interest. As the periods continue, I'll start to pay more and more principal. In other words, each payment will consist of more principal, while each payment will consist of less interest. I'm going to focus on what's referred to as the prospective method for finding these values. I'll touch on the retrospective method a little bit for the balance. The reason why you need both is because it depends on the question, really. And sometimes you may not have level payments, and things can get dicey. So bottom line is, and I'll probably do an example of this at some point, but the bottom line is that it may be useful to compute the interest paid during a period retrospectively as opposed to prospectively, depending on the information. And if you're confused about what this means, prospectively, say I want to pay the interest in year two, this is year two, okay, prospectively means I want to use all the future information to find out what interest I paid. Retrospectively, thinking back, if I wanted to find the interest paid here, I'll use all the information previously to figure out what I paid interest-wise in that period. So right now I'm going to focus mostly on prospective because the formulas there are nice. I've actually gone through the formulas for retrospectively, they're nightmare. Okay, I just derived them myself, checked that they work. These aren't in any books as far as I know, but I just wanted to see if I come up with something nice. Not really that nice, so I will maybe write down the formula for the retrospective balance at a particular year. But anyways, let's do some math, some real math. I'm doing this again basically just to ensure my understanding. I've officially signed up for the April exam FM. I'm a little nervous. I'm not really where I want to be with it, but I'm going to bust my ass and hopefully I can pass. I'll talk about that more later, though. All right, so where do we begin? First thing I want to talk about is the balance. Namely, let's just write down what is this loan equal to actually, right? So my loan is L, and the loan L, hopefully you can see, is just the present value of all of these payments. So hopefully you can see that the loan L is equal to the payment of R, and this is just the present value of annuity immediate. And I'm going to omit I, the interest rate I, whatever. We have an interest rate. It's not really relevant to what we're trying to do here, so I don't really care about that. All right. All right, good. Now, this is equivalent to saying that my payment each year is the loan divided by an annuity immediate with payments of 1, interest rate I for n periods. All right? So I'm not doing anything fancy, just dividing both sides by A sub angle M. Now, Why am I doing this? First thing I want to do is find out what is the balance in year one. What is the balance in year one? The balance in year one is equal to, if you think about this, it's equal to the balance in year zero, okay? In other words, the loan, right? Because that's the balance in year zero. I haven't paid anything, so that's the balance in year zero. And now I need to accumulate that to year one by taking 1 plus I. And now I need to subtract the payment. Think about it for a second. That's exactly going to be the balance right here. Is I take a loan, it gains some interest, and now I make a payment, take that off the balance, the accumulated balance, and then that will give me my balance in year one. So this is equal to, well, b sub 0, as I mentioned, I mean, what's the balance in year 0? It's just the loan. So this is the loan, right? Times 1 plus I minus the payment, which is L over A angle N. All right, that looks not too bad. Let's factor out L. Let's factor out L. So this is equal to, actually, let's factor out L over A angle N. L over A angle N. What's going to be left over? This is going to be A angle N times 1 plus I minus 1. Now, there are a lot of different arguments you can go through to figure out what this expression is here. Probably the easiest one is just to use the definition of A angle N. What I mean here is that this is just V plus V squared plus V cubed dot 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 plus V to the N. What as I multiply by 1 plus I, right? That's basically going to drop all those powers of V by 1. So I don't really want to write this out. Let me just make a little note right here. What is this piece equal to? There's different ways you can go about it. You can also use an annuity due, blah, blah, blah. But whatever, this is what I can say here is that this is V plus V to the N times 1 plus I minus 1. And think about this for a second. If I distribute 1 plus I, remember V is the reciprocal of that. So what is this going to be? This is going to be equal to 1 plus V to the N minus 1 minus 1. The 1's cancel, so I get V all the way up to V to the N minus 1. Oh, that's just what? A angle N minus 1. That's right. So this piece right here, let's just write that actually. Let's write that. So my conclusion here, all right, so let's just say this. This is exactly A angle N minus 1. Write it out. I mean, convince yourself. It's not too hard to see. So what I can say now is I have that the balance in year 1 is equal to that, is equal to L over A angle N times A N minus 1, like so. Now what I just did, by the way, what I just have done here is I basically said, what is this piece? How did I compute this? Did I use future payments or previous? I used previous. This right here is what is known as basically the retrospective. This is the retrospective method, and I hope I spelled that right. Spelling is not my strong suit. And what we've actually gotten to, this is actually the prospective method, and this is what usually the formulas are given in terms of, although this may be convenient at times. So this is the prospective. Now let me explain why that is. This is the prospective method, and the reason is because, think about what I'm saying here. What's another way of saying what the balance of year 1 is? The balance of year 1, if you think about it, is just, what do I have to pay? What do I have to pay after 1? Think about that. I made the payment here. What do I have to pay after this? What I have to pay after this is I have to pay this, this, this. So I'm taking the present value of all those. Okay, well, R is equal to L over A angle N. So I'm going to take all my payments and take an annuity immediate N minus 1 payments. So I'm going to take all of these back to year 1, back to year 1, back to year 1, back to year 1. That's why this is prospective, because I'm using the payments in the future. Prospective, using the future. Retrospective, using the past, because look what I did. I took the balance at year 0, which is the loan, I accumulated it, and then I subtracted that payment. So I'm using the past here. That's why it's retrospective. I hope that makes sense. And now I want to continue because I want to find B2. B2. All right, hopefully I don't run out of room here. Let's see what happens. B2, how am I going to find the balance in year 2? The balance in year 2 is exactly the balance in year 1 accumulated, so I'm using retrospective here again, accumulated 1 period, right? And then I need to subtract the payment I make at year 2. The payment I make is always the same because they're level payments. But then in this case, this is equal to, well, what is B1? B1 retrospectively is this piece. So let me write that actually. This is equal to L1 plus I, right? Minus L over A angle N times 1 plus I minus L over A angle N. This is the retrospective. Again, this is retrospective. In certain circumstances, you may want to do it this way. Okay? How would I get the prospective? Honestly, do some algebra here. If you sort of sort this out, factor out actually L over A angle N, you'll get the following. And I'm not just going to write I'm not just going to write this down. I'm just going to say to yourself, think about it a second. What's the balance in year 2 using prospective? Oh, well, it's all of these payments present valued to year 2. All right, well, if you think about this for a second, all of these payments, it's not too bad. I mean, B2, using the prospective method, it's just all of the payments, which are R, which are L over A angle N, brought them back. So starting here, bring them back to year 2. How many payments are there? There's n minus 2. So this is A n minus 2. And this is the formula for the prospective. Prospective. All right. Go ahead and give me shit about my spelling if you want. I don't know if it's right. I think it's right. I don't really care, honestly. I really don't care. So, moving on. I want to, I'm not going to write down in general. I have a formula in general for the retrospective method for the balance, but honestly, it's so messy. It involves a sum. It's just ugly. And in terms of doing it in problems, you just want to sort of work it out, sort it out as you go. I'll do a problem of it at some point. But now what I want to do is I want to say what is the prospective balance at year T in general, right? So let me get rid of all this business here. I want you to notice, look at my various prospective pieces here. I have this one and I have this one. All I need to really focus on is how does the index of B compare to the index of A angle N on this piece, right? I mean, these are exactly the same. These are exactly the same, right? So we pretty much, hopefully, I mean, this should be clear, right? You can just keep going through the same arguments if you want. Just continue, right? Find the balance year 3, year 4, etc. I'm just going to now write down this in general so that we can get to the principal paid as well as the interest paid in various years. All right. So let's go ahead and do that. So hopefully, I didn't actually write this down, but let me write it down now. BT is the balance at the end of year T. Sometimes this is also referred to as the outstanding principal, or really just outstanding balance. It's basically just what do you owe after you made the first T payments, right? Okay, we have everything we need, right? So let's just remember for a second here that B1, the balance of after year 1 was L over A at angle N. Remember, this is just my payments R, right? Remember that we have that. Let me write that down real quick again. Remember, L, the loan itself, is equal to R A angle N. So I'm not doing anything crazy here. This is R. Right? Just divide both sides by A angle N. And as we just derived a moment ago, this is A angle N minus 1, like that. We also saw that B2 is equal to L over A angle N, A angle N minus 2. Keep going, continue, see the pattern. It's quite obvious if you ask me. BT, the balance at the end of your tier. So in general, we have this. L over A angle N, A to the N sub angle, A angle N minus T. So this is what we have in general. So let me make a list of my formulas over here. These are my amortization formulas. Item number 1 is the balance. Okay? Item number 1 is the balance. Okay, so BT, the balance at the end of year T, prospectively, is L over A angle N, A angle N minus T. Okay, so this is the first thing I have. Definitely useful, quite useful. Next thing I want is to derive the principal. The principal paid in the teeth payment. So the way you think about this is like, say I wanted the principal the first payment. What I'm saying here is, this payment I made of R, how much of it is principal and how much of it is interest, right? I mean, because this loan accumulates interest, so when you make a payment, part of it's principal, part of it's interest. So I want to just say now, and I'm going to jump right to the general case. I'll stop beating around the bush. I mean, fine, once you have the balance, you're pretty much good to go. So prospectively, the principal, let's let PT be the principal paid in year T. And really, I guess I should say at the end of year T, because you make a payment, say in year 2, this consists of the principal you paid during that year. So hopefully that makes sense. Think about this logically. Just think about what the principal paid should be. If you think about it for a second, it's related to the balance. Okay, whatever I pay in, say, year 3, the amount of principal I pay is going to be how much the balance changed from year 2 to year 3. In other words, the principal paid in year T is exactly the balance in year T minus 1, the previous year, minus the balance in year T. Minus the balance in year T. So I will use the prospective formulation of balance to get this. So this is equal to now, so this tells me, this implies that the balance in year T, use my formula, this is L divided by A-N, okay? A-N, replace T with T minus 1, so be careful of parentheses, T minus 1, angle, minus, okay? Now we have L over A-N, and we have A-N minus T, right? So I'm just using my formula over there, right? Because this right here is BT minus 1, and this is the balance at year T. So using that formula, not too much going on. Now hopefully you can see what I'm going to do. I'm just going to factor out my payment, L over A sub N. So PT is equal to L over AN, and I'm left over with AN minus T plus 1, okay, just distributing, getting rid of the parentheses, minus AN minus T. Now what is this? What is this? These two quantities are almost the same. This is V plus V squared, all the way up to V to the N minus T plus 1. V plus V squared, all the way up to the N minus T. N minus T plus 1 is greater than N minus T. Everything, cancels except for the last discount factor in this present value of annuity right here. So do some algebra. I mean, write the definitions is quite easy to see. This is equal to L divided by a n d to the n minus t plus 1. And that's my formula I want for the interest paid. Okay, so for the interest paid is equal to the payment, which is L of the payment each year, right? They're level payments, L over a sub n, at angle n, and then v to the n minus t plus 1. So that is quite nice. That is quite nice. And I'm sick of this pen. So, last thing I want is the interest paid. I have the principal paid, now I want the interest paid. So, let's go ahead and write that down. We have everything, really. So, I just need to write it down. It's pretty easy, I think, to see at this point. The only thing you need to really consider when trying to find the formula for the interest paid in year T is just, what logically is going to give you that? What logically will give you that? So, let's let IT be the interest paid in year T. Think about this for a second. How much, say, interest am I going to pay in year 3? If you think about it, what it's going to be, it's going to be what the payment, right? I make a payment of R. If I take the payment and I subtract the principal, that's how much interest I paid. Think about it this way. Shouldn't this be true? Shouldn't your payment, as I mentioned, think about it, it's part principal, part interest. Let's just say, let's say RT. RT is the same as R, right? RT, what I'm saying here, this is the payment in year T. It's the same as R. It's always R. This is equal to the principal in year T, paid, plus the interest paid. Isolate IT. All right, this is what I want. I want interest paid in year T. So what I can say, so therefore, get I sub T by itself. This says that the interest paid in year T is equal to the payment, which is R, minus the principal in year T. So therefore IT, the interest paid in year T, is R, which is L over A angle N, minus the principal paid, which is L over A angle N, V to the N minus T plus 1. Factor out the payment, so this is L over A angle N times 1 minus V to the N minus T plus 1, and that does it. These are all prospective formulas, but nonetheless, they are useful. So let's write down, this is the principal, damn it. This is the principal. Sorry about that. The interest is what we just found, and this is equal to the payment, the level payment, times 1 minus V to the N minus T plus 1. So these are, over here, these are some useful formulas for amortization. You have the balance at the end of year T, you have the principal paid in that year, in year T, and you have the interest paid in that year T as well. Next type of video regarding formulas is I'll make one regarding the sinking fund. Sinking fund is not too difficult either, honestly. For whatever reason, people seem to have trouble with it. I don't know. Anyways, that will be coming soon. Tell me what you think. I hope this was helpful, and please subscribe to my channel, and thank you for those of you who have subscribed. All right.